Okay, on this video, what I want to do is to go over again, the book is Savitch, 10th edition, and we want to go over section 4 of chapter 2. That's a simple flow of control, and that's what is this video about. So we're going to be talking about some flow of control. So if you look at your program at this time, when you start the program, it's going to go on the top and it's going to start executing each line at a time. So first thing in your program is going to be pound include. It's going to go and do that one. Then it's going to go to your main. It's going to go in declaring variables. They're going to do those things. So if I don't say anything, basically it's going to keep going. So if I am on a freeway, driving, then they're going to give me a sign of where I am right now, but that's not changing anything. I'm just going to keep driving. So in this case is 8 West. I see the sign, but I'm not doing anything. I just keep going. Then the next one is called a branch. Branch is when we choose between two alternatives. My example for the freeway, you get to a point, it says, okay, you got to go either to north or south. So you have to check to see where you want to go. So if your plan is to go to north, then you have to take that route. And if your plan is to go to south, you have to take that route. So basically you have to make a decision. And that's what the branching is about. The way that we're going to do branching in C++, we're going to use if statement. So if I go back to my previous slide, I have to make a decision here. Do I want to go to north or do I want to go to south? And that's the decision I have to make. Another example here is if we are calculating the time for the hourly wage employees, then sometimes we got to see if this person worked more than 40 hours. So if the person worked more than 40 hours, we have to calculate the overtime. In this case, we are calculating it through 1.5, meaning that we are paying this person 50% more if they work overtime. So how do I calculate it? I'm going to have a rate. The first 40 is going to be, the rate times 40. And after that, whatever is left over, let's say I work 45. So I'm going to deduct the 40 from 45. That's 5 hours left over. I'm going to multiply by rate and I'm going to multiply by 1.5. But if I didn't work over 40, whatever hours I have, I multiply by 8. So the condition that I have to check is if this employee worked 40 hours or more. Actually, 40 hours is okay, more than 40 hours. So we're going to have a statement that's going to check to see if they worked 40 hours. If that's the case, if they work more than 40 hours, that means I have to calculate my overtime. That's the formula I'm going to use. If I am not, so if it's true, I'm going to calculate with the overtime. If it's not true, I'm going to calculate it without the overtime. So the word if is going to be used for the condition that I'm checking, and then the else means otherwise. So if it's more than 40, I'm going to do this. Otherwise, I'm going to do this. So either one. So back to the picture that I have for the freeway, I cannot go both freeway north and south at the same time. I have to choose which one I want to do. And when I chose that, then I'm going to be only doing one of them. So in this case, I am either going to have overtime or otherwise this. So only one of them are executed. For the efficiency part, I usually put the things that's most common on the top. because if this is the most common one, we're going to execute this. We are not worried about the else. So to take a look at some of these in a program, what we're doing here. Let me put these things down here, and I'm going to grab this and put it down here. So we are looking at display 2.8, and that's the program that we are looking at for the if-else statement. So that's the if and else statement that we have. Remember, we talked about the input processing output. So this is our input, getting the hours from the user. That would be my input. That would be the declaring variables that I need. So I have to sit down and think about it. What is it that's coming into my program? What is going out of my program? All those data have to have the declaration for it. The output, I'm not worried about initialization. And the input, we have to be careful that if it's going to be used in the processing, I have to be sure it's going to be having some value in it. So if I'm looking at the gross pay equal rate times hours, I have to be sure that the rate and hours are having some value in it before they get here. As I mentioned before, if they don't have any values, then they're going to have some weird numbers in it. So we have to check those things. When we're doing our output, we're always going to be thinking about how do we want to format our output. So this whole section is my output. This is the way we're going to format it with a 2 decimal point. Remember, we need the make it fixed, show point, and precision. And when we run this, this is what we're going to get. Let me move this one on this side and move this one on the other side. Just have a little more on it. Okay, so that's the way we're doing the if statement. And now, sometimes we're going to have more than one statement. So I want to pay attention to this, that if you only have one statement, you do not need braces. But if you have more than one statement, then you need braces. I did work in a company that they were asking us to use braces no matter what. So even if I had one statement, I was required to put braces around it. But for now, if you just have one statement, you don't need braces. Same thing goes with the else. So you need to have braces around it if it's more than one statement. And they are not related to each other. So you can have an if statement with one statement and else has more statement or vice versa. So just because I have braces over here doesn't mean I have to have it in the other one or vice versa. Okay, so we have something called Boolean expression. If you take a logic class, which is in philosophy or other areas as well as in computer science, there is a course called logic, and they talk about these things over there. And so the Boolean expression for us is just either true or false. So let's say that I am driving and I get into the intersection. If there is a stop sign, I'm going to stop. And if it's not a stop sign, I'm going to just go. So it's either or. So that's what the Boolean is going to be. Either it's true or it's not. Either it's going to be a stop sign there or it's not. There is no other options for these intersections. I mean, you can take it further and talk about some other things, but that's what I'm trying to get at. So when we're talking about the Boolean expression is when we have expression at the end is going to be either true or it's going to be false. So if I am looking at this expression either going to be true or it's going to be false. And that's where we're going to put it in the if. So if it's true, it's going to do the first one. If it's false, it's going to go to the other one. It cannot be anything else. So that's the whole concept of computer system. It's going to be 0 or 1, 0 being false, 1 being true. And that's what the Boolean expression is, either true or false. That's it. There is no other way of doing it. So we can have different operators that we can use. So for example, we can have greater than equal. So here, when we say hours greater than 40, that means it has to be, let's say, anything more than 40. That means 40 is not acceptable. So if I work 40, I'm not going to get overtime. But for some reason, my manager decided, you know what, all the people who work 40 hours are going to get something, whatever. So if I want to include this part, then I'm going to be using greater than equal. We can have less than equal. We can have not equal. And the one that we're going to be using a lot is going to be equal. So for the equality, I have to check to see both sides are equal. And the not is going to be if it's not that. Your author and I are asking you not to use this not as much as possible, because sometimes, especially if we have compound expression, it's not doing what you think it's going to do. So our English language sometimes doesn't match with this not very well. And we talk more about it. So these are some of the symbols that your display 210 has it. It says what math symbol is it, what is it in the C++, and the example that we have here. So what we're going to be using, of course, is going to be this middle part. The math one's not necessarily going to work all the time for us. So that's what we're going to do. So age greater than or equal 21, time less than or equal limit, count less than is, and if answer is not equal n, again, that's a character, and so on and so forth. Now, so if the Boolean expression is true, we're going to do the statements or one statement, and if it's false, we're going to do the rest of them. Now, we can sometimes have more than one thing. So I want to check the age of somebody, and I want to check something else. So Air Force wants to know if your age is, let's say, 18, and you have to have certain height for some reason. So I have to check two things, the age and the height. Now, we are using and over here. And means both condition has to be true at the same time. So if you're taking a logic class, you haven't taken it, or you're going to take it later, it's going to talk about something that's true on both of them. So you might have something true on this one, something true on the second one. We don't care about those things. They have to both be true. So if we create a table for it, if the first one is true and the second one is true, the whole thing becomes true. Otherwise, everything is going to be false. So the only condition that's going to be important to me is both of them are true. So in this case, I have x greater than 2 and x greater than 7. So what number do I have here? And x is an integer that is going to satisfy this. So it has to be greater than 2, and at the same time, it has to be less than 7. What number is going to be that? Greater than 2, that should be 3, 4, 5, 6. I cannot have 2 or 7 because I don't have equal sign on them. So those are the numbers that are going to satisfy this if statement to be true. So if I come in with X as a 3, 4, 5, 6, this whole thing becomes true. If X is less than 2 or equal to, then the first one is false. If X is 7 or greater than 7, this becomes false. And then the whole thing, if either one of them is false, the whole thing becomes false. And the symbol for and in C++ is these two together. So that's the way we're going to show and in C++. The next one is or. The symbol is two straight line. That would be the shift backslash, the two of them together. So the or, it says either one of them is correct. I'm going to be okay. So as far as it does exist in this, either one of them, I'm okay with it. So if I look at the table, if the first one is true or the second one is true, then it's going to be true. So the only time is false if both of them are false. So I give you two problems to do. So I'm going to ask you, do problem 2 and 5. That means if you want the whole credit, you have to do both of them. Now, I might come and say, you know what? You guys are very busy and all those things. I'm going to give you a choice. Do either 2 or 5. So if you go and do number 8, you're not going to get any credit. So you have to do 2 or 5. And even if you're overachiever and you do both of them, we're still going to be okay for the or. So if you do both problems, you have more harder, but that's okay. We're still going to be okay. So either or. And the not is going to do the opposite. So whatever is true is going to make it false. Whatever is false is going to make it true. Again, this not can make expression difficult to understand. And sometimes it's just, we are thinking one way and it's going to happen the other way. And that is why we are suggesting not to use not as much as possible. So the first case, I have X less than Y. So let's say X is 2, Y is 5. So 2 is less than 5, but the not is going to make it false. So if X is 5 and Y is 5, this expression is going to be correct. And that is going to be true, but the not is going to change it to false. So if it's true inside the parentheses, it's going to make it false. If it's false, it's going to make it true. So when we are using expression in this format, that's the math format. We do not have that in C++. So we have to show it in here like this. So we're going to break it and we're going to say X less than Y and Y less than 0. So this is not going to work. So your compiler is going to compile complain about it, and we cannot do it. Now, if you are new to programming, especially for C++, you might get some mixed up with the assignment versus comparison. So equal sign is for assignment. You're going to put something in it. Equal is going to check it. It's going to compare it. So I go to a coffee shop. I ask for a cup of coffee. They're going to take a cup and they're going to put it in there. And then they might say, here is your cappuccino. And I tell them, hey, I didn't want cappuccino. I want a regular coffee. So what they do, they take my cup, they pour it out, and they put the regular coffee in it. The reason I'm saying that, when you're using the assignment, even if you had something in your container, it's going to go away. This new thing is going to be replaced on that. And I'm mentioning that because we're going to need that for some stuff that we're going to do. Now, the comparison is going to compare two of them. In this case, it's comparing X versus 3. So if I want to go to my coffee example, then I'm going to compare the two to see if they both have regular coffee, they both have cappuccino, they both have whatever other coffees are. So I'm comparing between those to see if they are equal. So remember, this one is going to return true or false. Okay, so are they both cappuccino? Yes or no? Are they both regular coffee? Yes or no? But in the assignment, you just put it in there. You're not asking any question, you just put it in there. So assignment is going to take the right side and it's going to put it on the left side. Now, a very common mistake that we all do, and I honestly have seen this in industry, making things go haywire because somebody didn't pay attention. No, I have done it. So instead of thinking about comparison, we might come up with this, which is wrong. This is not comparing. So let's see what happens with this. So what happens is it's going to do the parentheses first. The parentheses first is saying x equal 3. So what does it do? It's going to take this and it's going to put it in x. So this whole thing becomes 3. This whole thing becomes 3. In C++, if you have a 0, that's false. Any other numbers are true. So 0 is false. Any other number is true. That means 235 is true, minus 83 is true. 76 is true, minus 155 is also true. The only thing is false is 0. Now, because of this statement, 3 goes to x, and the whole thing becomes 3, then this statement is always true. It's not comparing if x is true. X can be 255 originally, then becomes 3. It can be 0 originally, and 3 is going to go there. So it doesn't matter what the x was originally, like my first cup of coffee, they're going to throw it away, whatever is in there, and they're going to put the 3 in it, my regular coffee. So no matter what happens, I have a regular coffee here. And it's always, no matter what question I ask, it's always going to be regular coffee. I'm not comparing it with another one. So just keep that in mind, that 0 is false, everything else is true, and be sure you don't use the single equal sign for a comparison. All right, so we're going to put some expression, and those expressions always going to turn into either true or false. If it's true, we're going to do these statements. If it's false, we're going to do the rest of them, the other side. So in this case, I'm asking if my score is greater than your score. If that's the case, I win and I get some money. And if it's not the case, then I wish these were golf scores or whatever, and I'm going to get 0. Okay, so I want to put a pause on this video, do this activity, and to kind of understand what's happening up to this point before I move on to the next part of section 2.4. This 2.4 has a little more than what I wanted to have, but that's okay. We get there. So put the video on pause, do this activity, put it on the site somewhere. We're going to talk about it in the class, and then you can go on to the next section. So I hope you do that. All right, the next section, we are talking about loops. So loop, we're starting with this loop. It's a condition that you're going to keep doing. You're going to keep doing till your condition changes. So my thinking of this is you're going to set, check, and change. So in this case, I'm setting my countdown to 3. I'm putting a comment here explaining what I'm doing here. Then the next is I'm going to check to see if countdown is greater than 3. Remember, if my count was 0 or -1, this condition would be false. And then I'm going to be doing this, whatever is inside here. It can be a lot of things or just can be a few things. But the most important part is I have to change it. Because if I don't change it, then it's going to keep doing this. So let's look at this picture on the top. It's going to be a racing, let's say it's for car racing. So the check for me is going to be the gasoline. If the car has gasoline, they can go around this as many times as they want. Let's say I am in the practice, I want to just get used to this and I just want to drive. So the check is if I have gasoline. So I have to be sure, or somebody has to be sure, that my car has some gasoline in it. So we're going to put some gasoline in it before I do anything. Then I'm going to check it. So, okay, do I have gasoline? Yes, I have. So I'm going to be driving around and driving. And my gasoline is going to be consumed till I am going to be out of gas. Then I have to stop. Or if my gas is in 1/4, I have to stop. So the condition is going to change. So I am going to set it. I'm going to check it. And while this condition is true, I'm going to keep doing it. I am a student in a class. And while I'm not getting a passing grade, I have to take the class again and again and again and again. So if I never ever pass the class, I just have to keep taking it. And can I move on if I don't pass the class? So if you want to see this in a program, that's the program display 2.12. That's using the while loop. So we need to be sure that we are setting our countdown because we are checking it. So in this case, we are reading the countdown from the user. So we are asking how many times do you want it? So the user is going to put it. Remember, if I am doing declaration on countdown, it is not 0. It's something in it. I displayed that in my previous video. So be careful with that. If I didn't ask it from the user, there is going to be a number here and we're going to have some different condition. So we are reading it. So remember the set. So we are talking about set, check, and the change. So I'm setting it right here. I'm asking the user how many want. I'm going to put it in the countdown. Then I'm going to do my check to see if the number is greater than 0. Again, the construction of the while loop is in a way that if the number that the user put is not positive, it's not going to do anything. So if the user comes in, I ask the user, how many greetings do you want? And if the user puts 0, I'm not printing anything. I'm just going to go out. So if this condition is false, it's going to jump out of the braces. But if it's not, then it's going to do this C out over here. And the most important part, I have to be sure this condition is going to change. Otherwise, I'm going to be in this loop forever. I'm going to run it and then things are just going to keep going. Be sure you're going to bring your questions to our class so we can talk about it. All right, so that's what we were talking about, the setting, checking, changing, and so one of the things that we can do wrong is we get used to putting semicolon all over the place. And if I put a semicolon right here at the end, remember what's going to happen. my whole thing is going to end here. See, right now my while loop is going to end right here. But if I put a semicolon is going to end my statement is going to end right here. It doesn't go even to the next line. And because my condition is not changing, it's going to keep doing this, which is just basically checking my variable. So it's checking. And because it's not changing, it's always true. So it's going to stay here forever. So do not use semicolon at the end of your while. So that's what it's talking about. Again, with the while, if you have only one statement, you do not need braces. If you have only one statement, you do not need braces. You can put it in there, but you don't need it. Okay, do while is upside while. So with the do while, first of all, we're going to put the word do over here. And then we're going to have our while in there here, just a backward while. And then we're going to have a semicolon to end our while, do while. I was trained not to use do while. I never ever used it my whole life. I always use the while loop because it's more structured. It's presented here. We're going to look at something that you're going to be doing in this class. So the idea of the do while is, remember in the while loop, if the condition was false, we wouldn't do anything. But in the do while, you're going to be doing something before you check. You're going to do something before you check it. So if you show that you want to do something before you check it, the do while is for you. But again, I'm not using do while at all. So that's the do while. Again, if you just have one statement, you do not need braces. If you have more than one statement, you need braces. The key is you have to have a semicolon here. While loop does not need semicolon. Do while has to have semicolon. So if we look at this, this is something that you will gonna put it in all your programs moving forward. So let me write it down here. Do this in all your programs. Let me. Okay, so we're going to do this in all your programs. Let's see what happens. This is just by itself, but you're going to do it in your programs. So with the do while, I am setting and changing right at the bottom of my do while. So I'm going to do this stuff, and then I am going to read something from the user. And basically, I'm changing my variable A and S, which is answer. I would put it as answer. So if the answer is lowercase or uppercase y, I'm going to keep doing this. So we are asking the user, do you want to continue? And if the user said y, character y, then we're going to continue. We're going to run the program again. So we're going to put this around our program. If I want to take this one and make it as a while loop, when I declare char A and S to be like this, I don't put an A and S, I would put answer, but let's say I put it like here. So in what condition it would work the first time? I'm going to put a capital Y in it. And then I'm going to say while answer is equal single quote capital Y, or answer equal single quote, lowercase y. I put this one on top of my program. And then I put my whole program over here. And then I'm going to ask the user again, do you want to continue? See out. Do you want to continue? And then I'm going to ask the question. I'm going to tell them that what I'm looking for is Y or capital Y. And then I'm going to do cin on ANS. So this is the same thing. I'm doing it with the while loop. So either one is fine. The thing is, you're going to ask the user, if the user put lowercase or uppercase y, I'm going to go and do the whole program again. If the user puts n or x or anything else, I'm going to terminate, I'm going to get out of here. And in this case, it says goodbye, and we can put that one after these. And \n to go to the next line and so on. So either one, your whole program is going to be inside here. Now, you have your declaration on the top and your whole program is right here in the body. Now, when you ask the user, do you want to continue? And the user says yes, the first question that you have to ask yourself, is there any variable that I have to reset? Is there any variable I need to reset? So I'm running the program and then I ask the user, say, do you want to continue? The user says yes, I'm going to do the program again, but there's going to be some stuff that I have to reset. For example, I am doing some calculation and my total is going to be a previous total plus current total and so on and so forth. So if that's the case, I'm going to go inside here on the top of this while loop, I'm going to set my total to 0. I am not going to put my declarations inside of the loop because every time I come back here, I don't need to redeclare all my variables. It's going to work, but you're making your computer to work harder. So all my declaration is going to be above these things. So it's right here. So the declaration is going to be here outside of these. And if I need to reset something, I have to do it here. If I don't reset my total, it's going to carry over my previous total. And that's not what we want. And we practice this as we go forward. So you got to have this in your program from now on, meaning that every time you do a program, you're going to ask the user at the end, do you want to continue? And if the user says yes, you're going to run the program again. You're not going to close it and run it again. Okay, now the next topic is talking about increment and decrement. So we're starting with unary operator. Unary means 1. So this unary operator is just 1. So it's just like +5 or -5 and so on. But the most important one to us is increment and decrement one. So in this case, when we say plus plus, that means add 1 to it. Just like C++ is like increment of a C language. So we can write this in 3 formats. I can write counter equal counter plus 1. I can say counter plus equal 1, or I can say counter plus plus. So all of them are the same, of course, not a capital C here. All of these things is the same. and we have it for the other side, that would be the minus minus. That would be the same thing, counter equal counter minus 1, counter minus equal 1, counter minus minus. For the newcomers, maybe you're going to be more comfortable to use the first statement to kind of make sense before you do it. But you after a little bit of practice, you're going to be fine. You're going to be able to do it. And it's kind of weird at the beginning, but you'll be okay. So this one is a little program for you to practice. So again, put a pause on the video, go and try this, and we can work on it together. So the bank charge card balance of 50. So this is what we have before our loop. So if we want to say set, this would be my set. So I have a variable set to 50. Now it says that there is a 2% per month interest. How many months without the payment before your balance exceeds $100? So what am I checking? I am checking my balance. So I set it to 50. I'm checking to be sure it's 100 or above. So if it's 100.2, 100.3, 101, then I'm going to stop. So we're going to be running this. And then I have inside of my loop, I'm going to have some kind of a counter that's going to count to see how many months do I have. It can be as simple as month equal month plus 1, or it can be month plus plus. So keep in mind that if I say month equal month plus 1, this month has to be initialized to 0 before all of these things. Otherwise, I'm going to have some weird number in it. So I'm going to start month 0, and then it's going to come at the beginning of my loop. It's going to do month 0, month plus plus, then it's going to be month 1, month 2, month 3, and so on. And the way we're going to be calculating it is going to be my, what do we call it? A balance is going to be balance plus the 2% times my balance. So balance equal balance. So the formula here would be balance equal balance plus 2% times balance. Of course, we could say balance plus equal. So the same thing. Remember, I'm going to give you different options. So these can easily be written like this. Plus equal 2% balance. And then my condition would be if my balance is greater. So my checking would be while balance greater or equal 100. And of course, I'm going to be, the first thing I'm going to do is month plus plus. So every time I go in there, my month is going to be calculated. After I'm done with this loop, I'm going to print the number of months. So that's what you're going to do for this one. Take a few minutes, put a pause, practice on that one, and then see where we can go with that. So again, if the condition doesn't change, if what we have here is not changed, then this loop is going to keep going. So in this case, we are putting set, remember set, check, change. We are doing all of those things. The biggest problem would be if I don't have any change here, so it would just keep going. Now here, this condition is never going to reach. So we started with 1, and we are checking to see if x is not 12, but we are adding 2 to it. So it's going to go 1, 3, 5, 7, 9, 11, 13, 15, and it's going to keep going. It never was 12. So we have to revise this. That's what I say, try not to use not equal as much as possible. Even with this condition, you don't even want to use equal. So you can change it to while x is less than 12. So as soon as it hits 12 or 13 or anything higher than 12, it's going to stop. So this is something that you want to keep in mind to do it. Okay, so this is going to end our section 2.4, and we want to be sure you practice on it and be ready to talk about it in class. So I am going to stop recording.